Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello everyone, I'm John. Nice to meet you. This time, I'll be taking you through mathematics, of course, where I work with senior 6 students in our unit number 4, right? It's about integration. That's why I call upon every senior 6 students, of course, with mathematics as the core subject, to join, to listen, and to participate so that you can know how to integrate or to evaluate integrals using the change of the variable. Of course, it is part 3. We had part 1, part 2, and now part 3. Means that already we know how to apply that method. But of course, there is a small change. The small change, it will come after this activity, right? Dear students, have or take your notebook, exercise book, and pen, of course, and evaluate these integrals. Of course, you use integration by change of the variable, right? Okay, now you have 1 minute to do that activity. So go ahead. Remember different formulas. Immediate or standard integrals. Different formula you know, they'll help you. Have you finished? Yes? Oh, very nice. Okay. Let us find the answer, the solution we'll talk about. Thereafter, we shall compare the answers with yours, isn't it? So for this, if you observe this integral, at least the numerator and denominator, you can write this integral as sine inverse of x times 1 divided by square root of 1 minus x squared dx. Means that 1 over square root of 1 minus x squared is the derivative of this arcsine of x. It's like integral of a function power n times its derivative, dx. And you know when you have this form, immediately you get f of x power n plus 1 divided by n plus 1, then plus c. Observing these two functions, for me, f of x is sine inverse of x. Means that the answer for that is sine inverse of x. N is 1, so power 2, divided by 2, then plus c, and I'm done. Also, if you want, you can let sine inverse of x equals z, for instance. So differentiating both sides, you'll be having dx divided by square root of 1 minus x squared, which is equal to dz. And when you go back our integral, you'll be having integral sine inverse of x dx divided by square root of 1 minus x squared, which is equal to sine inverse of x is z. Then dx divided by square root of 1 minus x squared is dz. And you get z power 2 divided by 2 plus c, knowing that z is equal to sine inverse of x. You'll be having a half sine inverse of x raised to power 2, then plus c, and I'm done. The answer are the same, isn't it? So for number 2, the integral of sine x cubed times cosine x dx, if you observe, this integral is not different from the previous, isn't it? Because the derivative of sine x is cosine x, isn't it? Means that this is the derivative, the integral sine x power 3 times the derivative of sine x dx. It is this formula, isn't it? Means that this is f of x, and this is, of course, derivative of the function. Means that I'll be having f power n plus 1, means that I have a sine x 3 plus 1 divided by 3 plus 1, then plus c, to get 1 divided by 4, sine 4x, then plus c, and I'm done. Likewise, you can let sine x equals m, for instance. Then differentiating both sides, you'll be having cosine x dx, which is equal to dm. Go back our integral, you have sine cubed x times cosine x dx, which is equal to sine x is m cubed, then cosine x is dm. Are we together? Is it clear? Oh, very nice. Thank you very much. Then that is m power 4 divided by 4 plus c. That is standard integral. Replacing m by c value, you get 1 divided by 4 sine x raised to power 4 plus c. This is not different from sine x power 4, like that. As you have the answer at this level. Number 3, we have integral of e power 2x divided by square root of 1 minus e power 2x dx. So by change of variable, the challenge is this expression under root sign. So we let 1 minus e power 2x to be t, for instance. I change the variable, isn't it? Then I'm going to differentiate both sides. I'll be having minus 2 e power 2x, because the derivative of 1 is 0, which is equal to dt. Here you have a dx. Means that e power 2x dx is equal to minus dt divided by 2. And you see e power 2x dx is equal to minus dt over 2, right? So we have integral of minus dt over 2 divided by square root of all of this is t, which can be written like nega half, right? Integral of t power half, that is be t minus a half dt, because you know square root of 2, t is equal to t power a half. Then putting this on the numerator, the sign change. So this will be equal to nega half t power nega half plus 1 divided by nega half plus 1, then plus c. The answer would be nega half T power, that's a half, yes, because this is like a 2 divided by 2 minus a half, divided by a half plus C, and you will be having minus a half times 2. T power half is square root of T plus C, right? Simplifying, I'll be having minus square root of T plus C, and replacing T by its value, I'll be having negative square root of 1 minus e power 2 x plus c, and I'm done. Check your answers with these ones on chalkboard. Are they the same? Hope they are. Means that you have understood our 2 first lessons, means that it is easy to continue with this method with other examples. But first of all, clap for yourself because you did a big job. Thank you very much. Now, let us continue. But there you see the answers are not different from what you have there. They are there, right? And then we have other functions where we use the integration by change of variable. Means that we are going to solve to integrate the integral of this form, p of x, ax plus b power n, and dx, of course, and integral involving p of x divided by ax plus b power n dx. Of course, for these two kind of integrals, p of x is a polynomial, yes, and the n is a rational, of course, a positive rational number. So how to integrate, how to evaluate those kind of integrals involving a polynomial as a product of polynomial and a linear expression, power n, or a polynomial divided by a linear expression, power n. The method is the same for both integrals. How the method works? The method is simple. You let this linear expression ax plus b equals, for instance, z. Then after, you express z or x, express dx in terms of dz. Then you express x in terms of z. Then you integrate with respect to the variable z. Then after, you replace z by ax plus b. The method is very simple. Let us continue with examples. You can have a 2 or more, but even I work on one example, it will be the same for all. The matter is to recognize the polynomial either on numerator or denominator, isn't it? So there we have an example. Let me prepare my chalkboard, but at the same time, you are thinking about that method. So you have a few seconds to think about that. Yes? Then after, we work together. The method is the same, well expressed. Of course, when I'm preparing my chalkboard, please, you can copy down these ones in your record book for reference. You have 1 minute. Hope you are done, right? So let us have that example. Integral of 5x plus 3 times square root of 2x minus 1 dx. So you're going to apply the method. This can be written like integral of 5x plus 3 times 2x minus 1 power half dx. You see that? P of x is equal to 5x plus 3. And here, ax plus b power n is 2x minus 1 power half. Means that n is equal to a half. So applying the method, we let 2x minus 1 equals z. Then I differentiate both sides to get 2 dx, which is equal to dz. Means that dx is equal to dz divided by 2. Are we together? Oh, very nice. Now, I'm going to express x in terms of z. From here, from 2x minus 1, which is equal to z, I have x, which is equal to z plus 1. I move negative 1 to the right-hand side. Then I divide the both sides by 2. Are we together? Okay. Now, as I have the x and the x both in terms of z, I can even express 5x plus 3 in terms of z to get 5 times z plus 1 divided by 2, then plus 3, this is equal to 5z plus 5, then plus, is this 5? Yes. Plus 6 divided by 2, common denominator. And I get 5z plus 11 divided by 2. Is it clear? Okay. Now, we are going to integrate. Our integral becomes 5x plus 3 is here. That is 5z plus 11 divided by 2. Then, this is z power a half. Then dz, dx is dz divided by 2. I have these 2 and this 1. This is equal to 1 divided by 4. Integral of 5z plus 11 times z power half dz. It means we have a quarter integral of, when I expand, I will be having 5z power 1 plus a half is 3 divided by 2, then plus 11 z power a half dz. I hope you are following, and at the same time, if we make a mistake, you have to react. This is mathematics. Right? Yes, okay. Now, let us continue our exercise. This is the general form of integral of x power n dx. So we'll be having 1 divided by 4. This is 5 times z power 3 divided by 2 plus 1. That will be 5 divided by 2 divided by 5 over 2 plus 11 z power half. That is a half plus 1, which is equal to 3 divided by 2 divided by 3 divided by 2, then plus c. Means that you have 1 divided by 4, 5 times 2 divided by 5, z power 5 divided by 2, plus 11 times 2 divided by 3, z, here we have a z, power half. No, 3 over 2. Then plus c. Here you can simplify. Yes. And then I will be having these 2 appearing here. That is 2 divided by 4. Z power 5 divided by 2 plus 22, 11 divided by 3, z power 3 over 2 plus c. Are we together? So this is a half. I can take z power 3 over 2 in the factor. I remain with z, 3, yes, that is z, plus 11 divided by 3, plus c. So this is a half square root of z power 3 times 3z plus 11 plus c. I hope we are together. Then, replacing z by its value, I'll be having a half square root of z is equal to, where is z? It is there, 2x minus 1 power 3, 3 times 2x minus 1 plus 11. Is this 11? You have it to follow. Here you have, okay, I hope it is that. Then plus c. This is a half integral of 2x minus 1 cubed 6x minus 3 plus 11 plus c to get what is the answer? It is 6x, 11 minus 3, it is 8. That's a half. Square root of 2x minus 1 power 3 times 6x plus 8 plus c. I can factorize to get what? It will be square root of, there is a mistake here. When we divided by, the common denominator was a 3. Here it is a 3, which is forgotten. You add a 3, even here you add a 3, right? Okay. Divided by 3, yes. So it means that you have 1 over 6, 2 times 3, times 2. This is 3x plus 4. Then times square root of 2x minus 1 cubed plus c. Finally, we get 1 over 3 times 3x plus 4 times square root of 2x minus 1 power 3, then plus c. And I am done. Do you see? So it is not easy, but when you understand the method, you can make it, isn't it? All right. So I can give you another example or not because the method is the same. Isn't it? Now, you have an activity, of course, with a homework. Observe that the homework and the simple activity which is there, then we shall see whether I can help you or not. Give you 1 minute to think about that. Oh, we are back. Now, are you done? Can you have that activity? Is it necessary? No, I don't think so. You can try your best using the method, you know. Even the answer is there. Yes, you will see if you will get that answer. Then after, the homework is there. You have just a 6 exercise using the same method. The matter is to recognize the polynomial and the linear factor which will be assumed to be the new variable. I hope everything is clear. Thank you for your attention and participation. We shall have another kind of integration by change of variable, but very far with application of integrals. Thank you for everything. I hope to meet you next time. I wish you all the best.